Hello and welcome to StudyIQ. I am your friend Rahul Saigaonker. Let's continue our discussion of NCERT series. We are discussing the textbook for class 9. And today is the beginning of a new domain. We are going to start the discussion of physics in class 9. We are going to discuss chapter 8, that is motion. Now, before this, we have discussed some dimensions of chemistry where we spoke about matter, atom, the structure of atom, different models of structure of atom. Then we jumped into biology where we discussed about the fundamental unit of life, that is cell, cells becoming tissues, and then we understood about diversity, that is classification of living organisms. Today we'll start off with the discussion of motion. Here we'll talk about motion in a straight line, what is uniform motion, non-uniform motion. We'll understand the concept of speed, velocity, distance, displacement, what is acceleration, acceleration due to gravity. We'll also talk about some circular motion at the end of this session. Right, let's begin our discussion without any delay. But before that, there is a small notice for all of you, for all the UPSC civil services aspirant. Please let anybody who's interested in preparation know them about the StudyIQ's program, because 19th June is the date. Please mark your calendar because 3 batches are beginning. Of course, our English batch is beginning on the same date, but there is also availability of Hindi batch and English batch. That means both in Hindi and English, and pure Hindi batch is also starting from 19th of June, and all the 3 are prelims to interview initiatives. That means we will be hand holding you through your prelims, through mains, through your interview program as well. Right? If you have enrolled, it's a very good thing. I'll see you in the class. If you have not enrolled, if you know anybody who's looking out for these programs, please spread the word about StudyIQ's initiative of affordable education for all. Right? Please do it. Do visit our website www.studyiq.com. All right, let's talk about motion. Now, what is the meaning of motion? Motion means anything which is in movement, which changes its position from point A to point B. Motion means any body changing its position from one location to another location. And motion is a part of our life every day. In fact, right now I'm simply standing stationary. I'm talking, but I'm stationary. But if you look at it from a macro perspective, the entire universe is moving. We know the Big Bang, universe is expanding. The earth is revolving around the sun. Earth is rotating on its own axis. The planets are moving around the sun. So everything is in motion, right? Motion, it forms the basis of universe itself. The atoms, in the atoms, the electrons are moving. In our body, blood is moving continuously. So things are in motion at every point, at every second. But how do we describe this motion? Motion can be very complex. But in this particular discussion, we'll talk about motion in a straight line. We'll try to define certain parameters. How do we assess motion? How do we calculate different parameters or different dimensions connected to motion? We'll talk about motion in a straight line. It can be a motion in a circular path. We'll talk about circular path, or it can be a motion in any other kind. For instance, it can be oscillatory motion, it can be vibration. Motion can be different types. We have discussed about that in class 6, class 7. We'll build that knowledge. Today's interaction would be to understand motion of objects in a straight line. We'll try to express certain parameters. We'll try to define certain dimensions or variables, like what is distance, what is displacement, what is speed, velocity, all these things. Right, let's begin. First thing, how do we describe a motion? As I told you, motion can be very complex, but one of the simplest idea to describe a motion is an object moving from one point to another point. It may be in a straight line, it may not be in a straight line, it may be in a circular path, it may be vibration, oscillation, etc. But simply, a motion is something where an object is moving from one place to another place. That means now this particular point, it is called as the initial reference point. Say for instance, today to reach to my class, now I had to come from my home till the class to the office. So what is the motion? I have covered a distance from place, that is my home, till here. So I need a reference point, right? Now, when we say motion, how do we describe it? From a reference point, we see how far it has moved, from where to where it has moved, how fast it has moved. That means how much time did I take to reach. For instance, I reached from my home to office. How much distance I covered, how much time I took to cover this particular distance. I use these dimensions, these variables to describe the motion? Was it uniform? Say, for instance, if I came in 10 minutes, I covered a distance of 2 kilometers or 3 kilometers in 10 minutes. Was it by uniform motion? Was it non-uniform motion? All these things would be understood. Apart from that, in which direction did I move? I came from home to office. What was the direction? Was it due east? Was it due west? Or was it some other direction? Apart from that, what was the rate of the movement? Now, these are some of the variables that we need to understand to describe a motion. Now, let's talk about motion of an object in a simple straight line. As I told you, motion, the first parameter is how far something has moved, how far it has moved. Now, this is a reference point A and reference point B. As I gave you example of myself reaching from my home to my office. Point A is, say, my home, and point B is my office, right? Now, I have reached from here to here. We define two parameters to understand this motion. One is called as distance. Distance is a scalar quantity. Here, I do not look at the direction. I only look at how much distance, how many meters have I covered. All right. Say I started from my home. I took avenue A, and then I turn towards left, then I turn towards right. I don't look at these directions. I reach from point A, from one road to another road, from one road to another point B. This is the amount of distance that I covered. Again, distance is a scalar quantity where I do not bother about the direction that I take. It simply talks about the magnitude of how much ground I have covered, or how much ground the object has covered. From point 1 to point B, how much distance I have covered. There is another variable or another dimension that we can define, that is displacement. Now, displacement is a vector quantity. This distance is used to calculate my speed. We'll talk about speed in some time. Displacement is used to calculate my velocity. So by this, you already understand speed is a scalar quantity, velocity is a vector quantity, because distance scalar, displacement is a vector quantity. Vector means it needs to have some sort of direction. For example, I told you I came from my home to my office. This was the route that I took. But if I draw a straight line from A to B, that becomes your displacement, and this is the direction of displacement from point A to point B. So this is the magnitude, this is the distance, or this many meters I have covered, and in this direction, that is how displacement is defined. It's a vector quantity. So how far does it move through distance and through displacement? Always remember, displacement always has a straight lined path. Distance can have any kind of path, any curved path. Distance is the total ground or the total meters it has covered to reach the destination. The next aspect is how fast does an object move? How have I reached? I've reached from home to office. How? By how much speed? Now here, characterization can be done through two bases. One is through speed and another is through velocity. Now, speed is basically the calculation of your distance. Speed is basically the calculation of your distance that you cover, how much distance you have covered divided by how much time you have taken for traveling, the time of travel. This will give you the quantity speed. But when you talk about the idea of velocity, velocity is a vector quantity. For velocity, the time of travel, that means the denominator is going to remain same, but the numerator is going to change from distance to displacement. Clear? So these are the two variables that we use, speed and velocity. So speed is a scalar quantity, velocity is a vector quantity. It is ratio of distance by time, it is ratio of displacement by time, scalar and vector. Speed does not have any kind of direction. That means, say for example, I come from my home to my office, which is say 3 kilometers, and I cover that distance in 1 hour. So my speed would be 3 kilometers per hour. In 1 hour, I am completing a journey of by a speed of 3 kilometers per hour. Velocity is a vector quantity. Its direction, that means it simply takes displacement, meaning from home to the office, a straight line is drawn which talks about displacement, and how much displacement has taken place in how much time, that gives you the velocity. All right, so very important. what does this signify? Speed in any direction would be same. Say for instance, if a speed in one direction is 25 meters per second, speed in other direction would also be 25 meters per second. But velocity has a direction. If this is positive aspect, if this is positive velocity plus 25 meter per second, then this would be negative velocity. And say imagine I reach from my home to my office by traveling on a cycle, right? On a cycle, and at one point of time, and I'm traveling at a speed of 5 kilometers per hour. The next moment I'm traveling by 3 kilometers per hour. The next moment 2 kilometers per hour. So what would be my average velocity? Sorry, average speed. Average speed would be total distance covered divided by total time taken. So average speed is, it's a complete distance covered divided by complete time taken. Whereas average velocity, it differs. Average velocity is your initial velocity plus your final velocity divided by 2. Since the vector quantity, it is u plus v by 2. Please remember these things. Again, there is no need of numericals or solving mathematical problems here, but you need to understand the concepts from a UPSC examination perspective. So we have understood two aspects. One is how far do we move? Second one is how fast does something move? Direction is also very important, right? So if velocity is needed for us, velocity is important, then any aspect connected to velocity, it is connected to direction as well. The next is, how is the rate of this particular movement? If I reach from point A to point B by maintaining a constant velocity, constant speed, it's called uniform motion. There is no change in speed or velocity. So uniform velocity, uniform motion or non-uniform motion is the next aspect. Meaning, if I divide the entire journey, let me take up the board here. Say this is point A and this is point B. Now, if I divide this entire journey from point A to point B, it has some distance, some time traveled. Say x is the distance that has been covered and t is the time that has been taken to cover this. And if I divide this entire journey into different segments, then I will see that during this particular period, the distance would be same, the time taken would be same. That means x1, t1 would be same. So this is called as uniform motion. When I divide this segment, if you take any kind of ratio of distance by time, all these would be same. That amounts to uniform motion. But if these things are different, it becomes non-uniform motion. And many times in our life, we do not encounter with uniform motions a lot, right? Our normal transportation is actually through non-uniform motion only, right? But there are many examples of uniform motion. For instance, an oscillatory motion, a pendulum moving, uniform kind of a motion, or something moving at exactly constant velocity. That can be example of uniform motion. But many times we do have non-uniform motion. A non-uniform motion is one where there is no. A non-uniform motion is one where the speed or the direction it changes continuously. But for a uniform motion, the direction remains the same, the speed also remains the same. So for a uniform motion, at any point of time, the average speed would be the instantaneous speed, because at any point of time on a straight line, the speed or velocity would be same because the direction is also same. But here the instantaneous speed and average speed would be different. If you draw a graph of distance and time, uniform motion would be defined something like this, and a non-uniform motion would be anything, not just this. An example is this, but anything can be non-uniform motion apart from the straight line that I have drawn here. All right. Now, to define some other parameters specially connected to non-uniform motion, we know in a non-uniform motion there is a change in speed or there is a change in velocity. Either the speed changes or the direction changes. That means velocity is changing, meaning the body is either accelerating or decelerating. And this rate of change of velocity in a non-uniform motion, it is called as acceleration. It's called acceleration. Now, acceleration is defined by change in velocity divided by the time taken. And in simple terms, acceleration is defined, or acceleration is denoted as acceleration is equal to final velocity minus the initial velocity divided by the time taken of the travel. Now, what does this acceleration signify? Acceleration, again, it depends on velocity. That means it's a vector quantity. It depends on the direction. It can be positive, it can be negative. So say I am a runner. I'm running a 100-meter race. Initially, my speed is say 4 kilometers per hour. Suddenly, I start running fast. I increase my speed to 5, 6, 7, 8 kilometers per hour. That means I am accelerating. But after I reach my end point, after I cross the line, finish line, I would be stopping. That means I'll be reducing my speed from 9 kilometers or 8 kilometers to 7, 6, 5 slowly. That is called as negative acceleration. It is also called as deceleration or retardation. Please remember, acceleration can be positive or negative. It is defined as rate of change of velocity. And the classic example of acceleration can be understood from gravity concept. So you must have seen this. Now, in our physics, gravitational laws, they do tell us about the force of gravity. The force of gravity, Earth's gravitational force, G, is calculated by G into m by r square. All these parameters are connected to Earth because any other body, its mass would be minuscule in comparison to Earth's mass, that we know. And when we calculate this, Earth's gravitational force or Earth's gravitational constant, it comes out to be 9.8 meter per second square. And this is the unit of acceleration as well. The SI unit for acceleration is meter per second square. Please remember this. And acceleration due to gravity is 9.8 meter per second square. What does this mean? What does this mean? This means that if I drop anything from a height, Earth is attracting that particular body with some kind of force, gravitational force, and because of which the body is accelerating. With more time, with more height, its velocity increases. For instance, if I drop a ball which is at rest, meaning its initial velocity would be 0. But after 1 second, it is going to accelerate to 9.8 meter per second. Its velocity is going to increase at 1 second. The very next second, this is going to double, 2 into 9.8 meter per second. The third second, it is going to increase to 3 into 9.8 meter per second. Huge. You must have seen this. That is why, say, imagine if a coconut falls from a coconut tree and if it falls on your head, you're going to get injured. Why? Because it is falling from a height and it is traveling. Say, imagine if a coconut, this is not an apple, imagine this is a coconut, okay? At initial level, at t0, its velocity or initial velocity is 0. As soon as it falls, after 1 second, its speed increases to 9.8 meter per second. Next second, its speed is going to double. Third second, its speed is going to triple. The number of seconds it travels, its velocity is going to increase more and more. That is going to, it is going to accelerate more and more. And when we talk about the force with which it is going to fall, the force with which it is going to fall is equal to m into acceleration, how much it has accelerated, and that force would be immense. And if it falls on your head, that is why you get injured. That's why you must have seen in many animated movies, or if you've witnessed any videos or any graphic videos in which an asteroid it comes, or a meteoroid comes into Earth and it hits, it's going to create a huge dent. Why? Because it is coming with a mass and it is continuously accelerating because of the action of gravity, and once it hits the impact, it is going to create a huge dent. Right? We have known about meteoroid lakes. Example is the Lonar Lake in Maharashtra. It has been created because of a meteoroid entering into Earth atmosphere, eventually hitting Earth with a huge speed because of the gravity. All right? Right. Now, apart from this, we can also describe motion through graphical representation. We understood distance, we understood time, distance, time, speed, velocity. So we can draw different kinds of graphs to describe motion. And this is very important. Many a times MCQs can be formed asking or setting up these graphs and asking you what kind of a motion is it. So first we can draw a distance and time graph. Distance is drawn on the y-axis and time is drawn on the x-axis. And if distance is remaining exactly same, that means the body is actually not moving, meaning the body is at rest. This is the distance time graph of body which is at rest. And if the body is in uniform motion, that means it is moving at a constant speed, constant velocity in the same direction, then the graph would be something like this. This is a graph of a body in uniform motion. And if the body is in non-uniform motion, then the graph can be anything. This is a non-uniform motion. This is a non-uniform motion, right? Anything. It can be any kind of drawing. But this is a graph where the speed is increasing, and this is a graph where speed is decreasing. All right. But please remember, there can be some questions which can be framed when I ask you that if I calculate the area under distance and time graph, what does it signify? Please remember, distance time graph area does not signify anything. It does not signify any kind of quantity which is measured. All right. Again, from mathematical perspective, we can come out or we can arrive at something for sure, but the area in the distance time graph, it does not represent anything that we measure connected to motion. But the slope, when I calculate the slope of a distance time graph, see, this is the graph, and when I calculate the slope of this particular graph, it will give me the speed of that particular object at that instant. For instance, at this particular time, if I check out the slope, then I will get the speed of that object. So we can describe a motion in graphical way by creating a distance time graph. We can also create a velocity time graph, right? Velocity to be drawn on the y-axis and time to be drawn on the x-axis. Now when I draw this, and if it is a horizontal straight line, that means the velocity is not changing. With time, the velocity is remaining exactly same, meaning it is a concept of uniform motion. If it is uniform motion, that means there is zero acceleration. Now this is a graph for uniform motion. Zero acceleration, it's not accelerating. Similarly, if I draw a graph where velocity y-axis, time is on x-axis, and if I draw a line like this, or if it is rising, then it is constantly accelerating, and if it is going down, it is constantly decelerating. That means velocity is reducing with the time. That means it is retardation or deceleration. But please remember, when I calculate the area which is under the velocity time graph, I get the displacement of that particular object. When I calculate the area under this, I get displacement. And similarly, when I calculate the slope under the velocity time graph, it basically gives me what kind of acceleration is there. Is it positive acceleration? Is it acceleration? Or is it deceleration or retardation? So the area under velocity time graph, it gives me displacement. The slope, it is going to give me the acceleration. Apart from that, we can also draw acceleration time graphs as well, although this is not mentioned in the NCERT, but we can always draw acceleration and time. And if it is a horizontal line, you do know it is constantly accelerating. Again, it is a non-uniform motion where acceleration is constant, and this one is uniformly accelerating, this one is non-uniformly accelerating body. And area under the acceleration time graph, it gives me the concept of velocity. And whenever I get a slope, I calculate the slope of this particular graph, this line, then this is going to give me a concept called as jerk. What kind of jerk is felt? Is it a positive jerk where the movement is going forward, or is it braking? You can feel the jerk because of acceleration also, because of deceleration also. So at any point of time on the acceleration time graph, I calculate the slope. It is going to give me the quantity called as jerk, that is the rate of change of acceleration. Clear? Right. Again, on the basis of this, different mathematical questions can be created. Not very important for us, but they'll be very relevant in your physics concept, in your NEET, JEE, etc. All right. Now, apart from that, there is an idea of equation of motion. Now, for this, there is a lot of calculation, etc. It has to be done to prove these ideas, but equations of motions have already been defined. V is equal to u plus at, where this V is equal to the final velocity, u is equal to initial velocity. This a, it stands for acceleration, and t is the time instant. So there are three equations of motions which have been defined. V is equal to u plus at. That means final velocity is equal to initial velocity plus acceleration into time. Distance that is covered, it is equal to initial velocity into time plus half into at square, acceleration into square of the time, and v square is equal to u square plus 2as, or 2as is equal to v square minus u square. This is the third equation of motion. These are used in numericals. Many a times in examination, especially in 11th and 12th, you do get a lot of theoretical concepts on this. To prove how do you arrive at this, you can arrive at this from the graphical format or even through first principles as well. Now, whenever we are talking about a motion under the action of gravity, this A changes to G. That means V is equal to U plus GT for a motion under action of gravity. Similarly, S is equal to ut plus half gt square for a body under the action of gravity. Similarly, the third equation becomes v square is equal to u square plus 2gs, and g here is acceleration due to gravity. G is equal to 9.8 meter per second square. All right. Now, apart from this, we also need to establish some ideas about the circular motion, because we will be building on this in our subsequent classes. Wherever we get some basic ideas of physics which are relevant for us, we will be taking them. Uniform circular motion. Now, till now what we established is motion where something is moving from point A to point B, and if this point B is nothing but point A, we reached to a circular track. All right. Now, this is a rectangular track, this is different kind of shape track, and this is a circular track where once you start from point A, you will be changing your direction and you will be reaching to point A again. Now, this is called as a circular motion. A classic example being, you simply take a string, tie a stone to it and try to revolve that. You will get circular motion of the stone, right? Circular motion. And for any circular motion, the velocity or the speed, it is given by the distance traveled. How much distance are you traveling? For one complete rotation, you are traveling a distance of 2 pi r. And how much time do you travel to cover this distance 2 pi r? V is equal to distance by that particular time, where the distance is the circumference of that circular motion divided by the time taken. Now, generally, for instance, uniform circular motion can be seen on a track, on a running track, or uniform circular motion can be seen with your earth. Earth is revolving around the sun at a uniform circular rate. Earth is revolving around its own axis at a uniform rate itself. That is nothing but some sort of circular motion itself. All right. So this is the basics of circular motion. We will be building on this in our subsequent discussions as well. So please remember about scalar quantity. We have discussed that before. Scalar quantity is something which is only defined through magnitude. Vector is something which is defined through magnitude and direction. Distance is scalar, displacement is vector, speed is scalar, velocity is vector. If velocity is vector, acceleration is also a vector quantity. Do remember all these things and about simple ideas of motion. In our subsequent discussion, we'll move ahead and talk about another topic from physics. Thank you for watching this video, and if you've liked this video, you can always follow me on my social media handle @Rahul Sai 222. Thank you for watching this. Jai Hind.